Hello everyone, my name is Farah Nabila and I will explain to you about our topic of project, introduction and objective. Our topic is cinema booking system, visualizing virtual memory using FIFO and LRU. So the brief introduction of our project is the cinema industry faces challenges in memory resource management for online ticket sales and reservation, which it is necessary to have efficient memory resource management for a large-scale ticketing system. To address the challenges posed by the growing number of user requests, the traditional memory management strategies may lead to decreased performance and system instability. So in this project, we introduce a cinema ticket booking system that incorporates virtual memory management techniques as a solution to enhance system speed and efficiency. By introducing virtual memory as an abstraction layer that separates physical memory from logical memory, the system aims to overcome limitations such as restricted physical memory capacity, ineffective memory allocation, resulting in fragmentation and increased latency during data retrieval. So this challenge can negatively impact the user experience, such as lower ticket sales and potential revenue loss. In the end, this project explored the implementation of virtual memory in the context of a cinema ticket purchase system, presenting viable solution to optimize memory resources and improve overall system performance. Moving on to our objective, is to develop a virtual memory system that efficiently manages the booking process. We implement the FIFO algorithm to handle seat allocation when all seats in the theater are occupied. Next, we assign virtual seats as placeholder for individuals whose actual seats are moved to virtual memory due to FIFO replacement. Then, we utilize the LRU algorithm to handle seat swaps when all seats are occupied and FIFO has been applied. Next, we assign virtual seats to individuals whose seats are swapped out due to the LRU algorithm, indicate their actual seats in virtual memory. Then we provide a seat translation mechanism to allow individuals with virtual seats to access their assigned seat, whether in physical or virtual memory. Then we optimize seat allocations and swapping based on occupancy and usage patterns to ensure efficient memory resource utilization. Last is enhance the booking system performance, speed, and overall user experience. That's it from me. Thank you.
Okay, hi. So I will be presenting the methodology of our project. So the cinema ticket booking system will be developed using a web-based platform. So it will provide users with the ability to browse movie listings, select seats, make payments, and receive electronic tickets. So the virtual memory management component will be integrated to efficiently handle the large volume of ticketing data and optimize memory usage. Okay, so the system design will consist of 3 key components, which is the user interface, database management system, and virtual memory management system. The user interface will be designed to provide a user-friendly and intuitive platform for ticket booking operations. While the database management system will store movie information, seat availability, and user data. And lastly, the virtual memory management system will be responsible for efficiently managing memory resources using FIFO and LRU algorithms. So virtual memory management is a critical aspect of our project. So to ensure efficient memory allocation and utilization, so we have FIFO algorithm and LRU algorithm. So FIFO algorithm will prioritize the allocation of memory to the earliest requested seats, whereas the LRU algorithm will prioritize the allocation of memory to the most recently accessed seats. So these replacement algorithms will enable effective management of seat allocation, minimizing data retrieval latency, and optimizing system performance.
Assalamualaikum. I am Nuriman Hadi, and now I will explain about our cinema booking system as a visualizer for virtual memory, which use first in first out algorithm and least recently used algorithm. So imagine we have a theater with a limited number of seats available for booking. That will be representing the physical memory, which is RAM, and each seat corresponds to a specific memory location. To manage this booking system, we implement a virtual memory system using the FIFO and LRU replacement algorithm. So there are two scenarios, which the first scenario is when the booking is available. So initially, when someone wants to book a seat, they check if their desired seat is available in theater or not, which is in physical memory. So here, for example, we choose a seat, available seat. This indicate unavailable seat, and this indicate available seat. When we choose here, then it is available, so we can proceed to book. Then now we can just book it directly and occupy the seat. However, if their seat, their desired seat is already occupied in use by another person, the virtual memory system comes into play. So the second scenario is when the seat is fully booked. So I will explain. We are using first in first out algorithm. Now, as you can see, the seat is fully booked. We have to know that the virtual memory system will keep track on the order in which seats were occupied. It maintains a queue of the occupied seats, the earliest occupied seat at the front of the queue. So we can assume that the first row is the first occupied seat, the earliest occupied seat in the system. So when all the seats in theater are occupied, the virtual memory system applies this FIFO algorithm. It removes the person who booked this earliest at the front of the queue and frees up the corresponding seat in physical memory. So here, for example, we have want to choose and it will show there's no seat available. So we need to try again. And here the FIFO is happen. It will remove like I said before. This is the first the earliest seat occupied. So we remove the first person in this seat. And the first person in this seat, the person who lost their seat due to the FIFO replacement is given a virtual seat instead. Yeah. This virtual seat acts as a placeholder indicating that their actual seat is now in virtual memory. Now, you can see that we can book the seat. So next, if another person wants to book, so it will remove the person in here. The second seat, where it indicates that now the earliest seat occupied is here. Want to occupied this seat, we cannot, since it is already full, there is no available seat. So using FIFO, they will remove the person in this seat, and the person who lost the seat will go into virtual seat. So when a person in a virtual seat wants to access their book seat, they refer to the virtual memory system. The virtual memory system will translate the virtual seat number to the actual seat location, allowing the person to access their assigned seat, whether it is in memory or virtual memory. So here, as you can see, this another person can book so that's all from me. My teammates will continue present.
Hello, my name is Cherisha Justin, daughter of Sebastian, and I will be explaining about the LRU implementation. Now we will look at the scenario 2, which is the fully booked using LRU. LRU page replacement. When all seats are occupied, the virtual memory system employs the least recently used LRU page replacement algorithm to free up a seat for a new booking. So the following steps describe the design and implementation of the LRU page algorithm. First, the tracking reason usage. To implement LRU, the system maintains a data structure known as the LRU list. This list keeps track of the order in which seats were accessed or booked, with the most recently used seats at the front and least recently used seat at the end. Then each entry in the LRU list correspond to a person or a booking. Next, determining the least recently used seat. When all seats are occupied, the system examines the LRU list to identify the person who accessed their seat least recently. In this example, as we mentioned, assume that the seat C4 was accessed least recently. So this information is obtained by examining the position of the entry corresponding to the seat C4 in the LRU list. Next is the swapping out the seat. Once the least recently used seat is determined, in this case it is the seat C4, the system swaps it out from physical memory to virtual memory. This involves updating both the physical seat, making it an unoccupied and page table, reflecting the seat's new location in virtual memory. Then assigning a virtual seat. After swapping out the seat, the person who booked the seat C4 is assigned a virtual seat. The page table is updated to reflect the mapping between the virtual seat and the actual seat in their virtual memory. This ensures that the person can still access their assigned seat using their virtual seat number. Then updating the LRU list. To maintain the accuracy of the LRU list, it is crucial to update the position of a person who had their seat swapped out. This can be done by either moving the person to the front of the LRU list or updating their position based on their recent usage. By doing so, the LRU list reflects the updated order of the seat access and can be used for future page replacements. Next, accessing seat. Once a person with a virtual seat wants to access their booked seat, the virtual memory system performs the following steps, which is virtual to physical translation. The person provides their virtual seat number to the system. The page table is used to translate the virtual seat number to the actual seat location in physical memory or virtual memory. This translation then ensures that the correct physical seat is identified. Next, accessing the assigned seat. Based on the translated location, the person is granted access to their assigned seat. So the system then allows them to occupy the seat and enjoy their movie experience. Now we move on to the results and discussion part, where we will see the results and discussion from the designs we created. So now the virtual memory system for the movie ticketing system is incorporate the FIFO and LRU page replacement algorithm. So the system interface allow users to book seats, and if a seat is unavailable, the page replacement algorithms are invoked. FIFO replaces the earliest booked seat, while LRU replaces the seat accessed least recently. Users can access their assigned seat using virtual seat numbers. Next, the execution involves initialization, booking process, page replacement algorithms, and seat access. The FIFO algorithm ensures fairness, while the LRU algorithm optimizes seat allocation based on recent usage. The system interface simplifies seat booking and access. So, what we can say here is the virtual memory system efficiently manages seat bookings, prioritizing fairness or recent usage. Then the system provides a user-friendly interface for seat booking and access. So the choice of page replacement algorithm should consider the specific requirement of movie ticketing system. That's all from me.
Assalamualaikum and hello. My name is Siti Nurkamila and I'll be presenting on conclusion. So, there are few challenges that we faced during the completion of our project. The first challenge is to integrate virtual memory management techniques into an existing ticket purchase system. The second challenge is to select and implement appropriate memory management algorithm and caching mechanism. And the final challenge is to ensure seamless scalability and handling high concurrent user requests. So this project also have given us the extra knowledge on the field of memory management, system optimization, and system design. So our group also gain new knowledge in using virtual memory techniques, picking suitable algorithms, and taking scalability into account. This project also gave us the chance to learn more about the difficulties and complications of incorporating sophisticated memory management ideas into practical applications. So that's all from me. Thank you.